Hey guys, Miss Barber here, lesson 1.6 for geometry, midpoint, and distance formula. So we're going to use both the midpoint and distance formula today, as well as compare the distance formula with Pythagorean theorem, which you may have used in potentially 8th grade math or algebra 1. Don't worry, we're going to definitely get way more in depth with Pythagorean theorem later in chapter 5. So the first formula we're going to use is the midpoint formula. So this formula, we talked about midpoint in lesson 1.2. For the midpoint formula, this is when you're on a coordinate plane. So this is when you got those grid lines and an x-axis and a y-axis. You're going to use this formula to find the middle point or the midpoint between 2 points on that coordinate plane. So if you look here, we have point A, we'll just call it x1, y1, and point B, x2, y2. The midpoint M will be in the middle, so it's going to be the average of the x's and the average of the y's. To find averages, you add up and divide by how many you have. Well, we have 2 points, x1 and x2, so we're going to add them together, divide by 2. Add my y's together, divide by 2. We always put parentheses around coordinate points to indicate that they're coordinate points, so that's why those parentheses are there. One thing that's not written in the formula, but I like to add in, is parentheses between my x's and between my y's. The reason is if you're using a calculator, order of operations needs to take place. The fraction bars here act as parentheses with order of operations, meaning you need to add your x's together before you divide by 2. Add your y's together before you divide by 2. If you don't put those parentheses in your calculator and you try to do everything at one time, your calculator is going to give you the wrong answer because it's only going to be dividing the second x by 2 and not both of them. All right, so let's go ahead and try an example. Find the midpoint of the following coordinates. Letter A, 6, 4, and 3, negative 4. So I'm just going to label my first x, or my first 6 as an x, and my 4 as a y, and then again, x, y. Order here really doesn't matter, so you could put the 1s and the 2s in if you want. You don't need to. So I first have to add my x's together, which are 6 and 3. So it's going to be 6 plus 3. Again, I like to add the parentheses, divided by 2, comma, and then add your y's together. 4 plus negative 4. Again, I like putting my parentheses, divided by 2. And these are coordinate points, so we're just going to put parentheses around the whole thing. So using a calculator, there's a few ways you could put this in. You could do 6 plus 3 and press enter, and then that's 9, and divide by 2, and that'll give you your answer of 4.5. Or again, you could put it all in as once, you just need to make sure to add the parentheses. So my x-coordinate is 4.5. 4.5 is halfway between 6 and 3. For my y's, I'm going to add 4 and negative 4 together. Again, that's 0. Dividing by 2, 0 divided by 2 is 0. So that's my midpoint, 4.50. It's halfway between 6, 4 and 3, negative 4. Pause the video and try letter B. Again, don't forget your parentheses and order of operations. All right, letter C. M is the midpoint of segment AB. The coordinates of A are negative 2, 3, and the coordinates of N, so the coordinates of the midpoint, notice they gave me the midpoint coordinates this time, are 1, 0. Find the coordinate of B. So there's kind of an easier and a harder way to do this. I find most of the students kind of like to use the cheater method, which is how I'm going to teach you today. If you want to use the true algebraic method, be my guest. You can go ahead and figure that out. So I'm just going to draw a little picture here. I know I have a coordinate A. They told me A was negative 2, 3. M is in the middle, it's the midpoint, and M is 1, 0. I'm trying to find B, so I'm going to put B down here. Again, M has to be in the middle. That's what I'm trying, that's the middle between A and B. So if you think of this as a segment, got point A, point M, point B. M is in between, or in the middle. So now how this works is, if M is in the middle, it means it's the equal distance between A and B. So from negative 2 to 1, how do you get from negative 2 to 1? Well, I would think most of you would say, oh, well, obviously you have to add 3. So if you have to add 3 to get from A to M, you would have to add another 3 to get from your midpoint M to B. So you're going to do 1 plus 3, which is 4. So that's what your endpoint B is. You're going to do the exact same thing for the Y coordinate. How do you get from 3 to 0? Oh, well, you subtract 3. So I'm going to have to subtract another 3 because I'm going the same distance. So 0 minus 3 is negative 3. So that's my coordinate B. So example 1A and C are really the only two basically the only two things I could ask you for midpoint. So go ahead, pause the video and try D. It's the exact same as C. And be careful whenever you're doing an assignment or a quiz or a test that you're differentiating between finding a midpoint, like letter B and A, or finding a endpoint given a midpoint. All right. Next thing is the distance formula. So given 2 points, x1, y1, and x2, y2, so again, on a coordinate plane, in order to find the distance, which is, again, length, so sometimes kids forget that length and distance mean the same thing, so sometimes they'll use the word length instead of distance, you're going to use this following formula, which is the square root of parentheses x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Lots of order of operations are going to take place here, and you can always use a calculator. You just have to make sure you're entering it incorrectly. Well, the distance formula is actually derived from Pythagorean theorem. You might not remember Pythagorean theorem, but it is a squared plus b squared equals c squared, where given a right triangle, A and B are your sides, and C is opposite the 90, and that's called the hypotenuse. Doing the distance formula, we would be finding C. So C squared, or just the plain old C here, really, not the square, would be the same thing as AB in my formula. To undo a square, you would have to square root it, which is how we get if we take the square root here of both sides, we would have the square root of A squared plus B squared equals C. So that's how we came up with that formula. We'll see how both of them interplay. Technically, you could only ever use one or the other. You don't ever need to use both. Definitely don't need to do both at the same time. However, if you're given a coordinate plane, Pythagorean theorem might be easier. If you're just given coordinate points with no picture, the distance formula would probably be easier because Pythagorean theorem, it's a little more difficult without a visual picture to use. So let's see how they're both used. I'm given a picture here with points A and B. To use Pythagorean theorem, I have to have a right triangle. So I'm going to go ahead and draw in a right triangle connecting points A and B. I drew those really straight. Very proud of myself. And I actually need to find the lengths of these two sides. Well, here at the bottom, my base is 2 units, so I'll write in a 2. And my height looks to be 1, 2, 3, 4 units. Again, this is my C, my hypotenuse. It's what I'm trying to find, the length of AB. So Pythagorean theorem would tell me to write 2 squared, or A squared, plus 4 squared, B squared, equals C squared. Well, 2 squared is 2 times 2, which is 4. 4 squared is 4 times 4, which is 16, which equals C squared. 4 plus 16 is 20. And again, I don't want to know what C squared is. I want to know what C is. So I have to square root both sides to undo the square. Well, so that would mean the square root of 20 is C. And if I put that baby in a calculator, I would get roughly 4.47. So that's using Pythagorean theorem. Not too bad, and again, for the purposes of this lesson, we'll only ever be finding C. So not too bad. But if you didn't have this picture, it would be hard to figure out your A and your B, the 2 and the 4. So let's apply the distance formula. For the distance formula, I gave you what the points A and B are. That's the same coordinate points on there. It just made it easier for you. I like to set it up by writing the square root symbol, doing parenthesis, parenthesis, minus squared, plus parenthesis, minus parenthesis squared. So I kind of like having it all set up and then just substituting my numbers in. Again, your x's have to go together and your y's have to go together. So this is x, y, x, y. The order really doesn't matter, even though the formula kind of makes it look like it. So I'm just going to do my first x minus my second x. So 1 and 3 are my first x and my second x. And then my y's are 1 and 5. So I'm going to do 1 and 5. You are more than welcome to solve this out by hand. Remember, order of operations takes place. So first you have to do the parentheses. So the parentheses would tell me I would have to do 1 minus 3, which is negative 2 squared, plus 1 minus 5, which is negative 4, parentheses squared. And again, order of operations after parentheses would be exponents. So for the exponents, negative 2 squared, remember, is negative 2 times negative 2, which is a positive 4. Negative 4 times negative 4 is positive 16. Hopefully you're thinking, this looks very similar to what we just wrote right up there, because it is. It's the same kind of thing. Again, they derive from the same place. 4 plus 16 is 20, so the square root of 20, which is 4.47. So again, more than welcome to solve it by hand. If you want to use a calculator, so I'm going to go ahead and move to my graphing calculator. A good app is Taculator. It looks exactly like the graphing calculators in class. So if I was to use that, I would have to take the square root. The square root button, you would press the shift, the red button here, and then the x squared button, which gives me my square root. And then again, I would have to put this whole thing in parentheses. So first parenthesis, and then it's going to be 1 minus 3, close parentheses squared, plus, and notice my square root symbol is continuing up here. So make sure you're watching, parenthesis, 1 minus 5. If you don't type it in exactly like it's written, your calculator won't give you the same answer. So the whole thing is under the square root bar. I got the parentheses and the minuses and the squares in the correct place. I press enter, and notice I get my 4.47, and it goes on. It's an irrational number, so it'll continue. So you can more than welcome to also just put it directly in your calculator. It's personal preference. Some people don't like using a calculator. They like doing the mental math. You'll eventually need the calculator if you need the decimal answer. I assume most of you don't know all of your non-perfect squares. I know I don't. All right. So let's do another one. So here, example 2, letter A. They want me to graph the point negative 3, 4. So I'm going to go left 3, and it's going to be really hard to do on my iPad, but I'll try my best. And then up 4. So I did a dot. It's very small. Again, very hard to do on an iPad. And then 5, 4. So I'm going to go right 5, up 4. Again, hard to do on an iPad, but we're still trying our best. Okay, so if I was to connect these, you might think to yourself, that's just a horizontal line. I can't even make a triangle with that if I tried. There'd be nowhere to put the sides that are going horizontal or vertical. So in this case, you're just going to count. How much should I go left or right? Well, I went 8. So that's just the length. So for Pythagorean theorem, you don't even really need to do it because you can't form a triangle. Now let's do the distance formula. So again, I like to set up my formula without the numbers first, just to make sure I'm putting everything in where it goes. And then let's put in my numbers. My x's are negative 3 and 5. Doesn't matter which order, I'll put negative 3 first in and then 5. And then my y's are 4 and 4, so we'll put those in. I'm going to do it by hand, but again, more than welcome to throw this in your calculator. Negative 3 minus 5 is negative 8. I'm going to keep it in parentheses because it's still in parentheses squared. Plus 4 minus 4 is 0 squared. Well, negative 8 squared is negative 8 times negative 8, which is 64. 0 squared is just 0. Well, 64 plus 0 would just give me 64, so the square root of 64 is 8. I got the exact same answer, which I should. They're the same thing. So That's another example where Pythagorean theorem was actually easier than the distance formula. But if you don't have graphing paper, then you can't really use Pythagorean theorem unless you're very good at visualization. Let's try letter B one more time. So letter B, I have -4, -5 is my first point. So I'm going to go left 4, down 5. All right. Then my other point is 1, -2. Right 1, down 2. So this is the line I'm trying to find. Notice it's neither horizontal nor vertical, so I definitely can't just count like in letter A. Let's go ahead and draw in my lines to make it a triangle, and I gotta count. Well, my base here is 5, so that's going to be the first number I'll use for Pythagorean theorem, and my height here is 3. So for Pythagorean theorem, again, I'm going to use a squared and b squared. Order of those doesn't matter. So 5 squared plus 3 squared equals c squared, what I'm trying to find. So here's my c. 5 squared is 25. 3 squared is 9. 25 plus 9 is 34. And again, we have to square root. Square root of 34 is going to give me 5.83. So we can do the exact same thing with the distance formula. Again, set it up. Put your parentheses, your minus, and your squares. And then throw in your numbers. First, you're going to put in your x's and then your y's. So I have -4 and 1 for my x's. And for my y's, I have -5 and -2. Pause the video. Try putting this in the calculator. Let's try with our calculator. Again, if you have an iPhone, iPad, any Apple product, Taculator, which I use, is a free app. If you have an Android, Wabbit EMU works. There's probably other free graphing calculators. You just can search for them at the App Store. So go ahead and try. And again, we know we should be getting 5.83 as my answer, because it's going to be the same. And then you can go ahead and try letter C, checking your answer against the key that's posted. That's it for the distance and midpoint formula. Have a great